Okay, we're picking up on page 4 of the 9.3 notes for Algebra 2. And we had two separate cases where we were looking for horizontal asymptotes, and depended on the degree of the top and the degree of the bottom. Now this one is degree 3. And because of that x with the first power on it, this is first degree. And this third case is when the degree of the top is bigger than the bottom. When you have a degree of the p of x part, this part up here, that's greater than the degree of the bottom, then you simply do not get a horizontal asymptote. So you're just going to do this, HA, like that, or you might say no horizontal asymptote. And you don't see a horizontal asymptote. This thing goes up forever, up forever, up forever, down forever. There's no horizontal asymptote at all on this graph. A couple notes while we're here on horizontals and verticals. The graph of a rational function has at most one horizontal. So if you have, this one had none, and we've had a bunch of graphs with one, but you'll never get two or more. However, a vertical asymptote you can have lots of, several. There's one down at the bottom of the page. You see two vertical asymptotes there, but only one horizontal. Okay, that's kind of what I'm trying to get across in that first note up here. Okay, the second one is the graph of a rational expression will sometimes cross the horizontals. So if you got a horizontal asymptote, the graph may actually cross it. Let me show you the graph of number 7 on the previous page. Okay, you can see that this graph comes down here and crosses the horizontal asymptote. And that happens. Horizontal asymptotes, they cross. But a vertical asymptote, it avoids it like the plague. It comes up like this and gets closer to it, but it will never touch it. And just like Gandalf here, you shall not pass. It really can't pass that location, and you'll remember that it's undefined at that location. Okay, the next thing we're going to turn our attention to finding the zero function. And maybe you remember from previously in the course we learned that zeros are x-intercepts. And they're the places where the graph has a y value that's equal to 0. So if you think for yourself about how do you get a fraction to equal 0? Well, there's only one way to do it, and that's to get the top equal to 0. So to find the locations of the zeros of the roots, you set the top equal to 0 and solve. So let me show you, first of all, what we're looking for. We're trying to find the places where it crosses this x-axis. And this one crosses twice, one time at 3 and another time at negative 2.5 or negative 5/2. And the way we're going to find those locations is we're going to set the top equal to 0, and let's see what we can do to solve this. So I'm going to try to factor out a 2 here, and I think I can do that pretty easily. And then I'm going to see if I can factor this further. So let me set up a little star over here. My leading coefficient is 2. Product of the a and the c is negative 30. The middle one is negative 1. And now I'm trying to find two numbers that multiply to give negative 30 and add to give negative 1. Well, that would be 5 and negative 6. A little simplifying over here, and we now found 2x plus 5 is one of the factors, and the other one is x minus 3, and so this gives zeros at x equals negative 5/2. That's this location here, and x equals 3. Now if this were from the bottom, setting that equal to 0, I would call these points of discontinuity. but they're not here. They're zeros. or x-intercepts. Okay, so to make this simple, you set the top equal to 0 and solve. And you'll find the places where the graph crosses the x-axis. All right, we'll pick this up on the next page, page 5.